We are live, you guys. Welcome back. It was quite a spring break, wasn't it? We couldn't go anywhere, couldn't do anything. We tried to take off and see if we could go camping, but we couldn't go camping because nothing is open, so it was real kind of a bummer of a spring break. But anyway, hopefully this will be over and we can go back to normal. So anyway, let's go back to algebra, okay? So let's go back to our day. So first of all, Chapter 5 test. There are still, believe it or not, some of you have not even done Chapter 5 tests. It's like, you've got to get Chapter 5 test done. So Chapter 5 should be finished. If you've seen zeros in Chapter 5, then you are in big trouble. Get it done. Chapter 6, though, we did the last week before spring break, and most of you have Chapter 6 done. But if you have not taken Chapter 6 test, like C, we're moving on. So you've got to get Chapter 6 test done. And I will be calling, I'll be talking to parents, I'll be harassing you if you can't get Chapter 6 done, okay? So, we talk about today statistics, okay? Statistics is super important in today's technology. Everybody wants to know about statistics. That's our business world. That's our medical world. We want to know if you got a whole bunch of facts and figures, what do they mean? So that's what we're going to study. This next chapter is a thing called statistics. So I'm going to open up my journal, page 191. I want you to do the same thing if you have your journal handy. Let's go to page 191. Move that aside. To page 191 in our journal. Page 191, and let's look at these definitions, okay? And you can write these down as I go through them, okay? So, measure of center, okay? So you guys have all heard of like taking an average, find the middle, find the mean, and all that stuff. We're going to talk about that again today, but we're going to go a little bit beyond that because most of this is middle school stuff. So we're going to go from middle school stuff to some additional things. Okay, so first of all, definition. Measure of center. Well, it's a way to identify the center of data. Right? So you line a bunch of kids up and you say, okay, let's line it from the shortest to the tallest. Who's standing in the middle, okay? Now the mean, or average, the way we find the mean is we take and add up all of our numbers, add them all up. That's the sum, is to add them all up, and then divide by the number of numbers. Okay, again, you've done that, and we'll practice this here with an example, okay? The median is the middle number. So if you line up a bunch of kids, it's the middle number. Line up a bunch of kids by heights, right? By heights, right? You're looking for the middle kid. There's 1, 2, 3, 4, 5, 6, 7. The middle kid would be that guy right there, okay? That's in the middle. That's the median, okay? A mode is the most common. For instance, if there's 2 or 3 people that happen to be the same height, that would be they're the most common, so the mode is the most common data. Something occurs more. Outlier, okay, so an outlier would be, for instance, something that's either way too big or way too small, okay? An example of that would be if we wanted the age of our class and probably the mean age would probably be about 15 in our class, but let's say we had a 10-year-old genius. Maybe we had an 8-year-old genius. Or maybe we had, a 7th year senior and they're like 20 some odd years old. That would be an outlier because it would really ruin our data. Something either way too big or way too small would be an outlier, okay? Measure variation. So what happens is you can have really spread out data or really compact data, okay? An example, if you guys are listening, believe it or not, the mean temperature of San Francisco is the same as the mean temperature in Kansas City, Missouri. They're about 57 degrees for the whole year. However, San Francisco never gets very cold, never gets very warm, but Kansas City, Missouri gets super cold and super hot. So they'd have spread out data or really compact data. And we'll take a look at that and a better example of that later, okay? The range is just the biggest minus the smallest, like if we knew his height minus his height, okay? Standard deviation, we're going to learn, it's a measure to determine how spread out the data is. The bigger the number, the more spread it out. The smaller the number, the less spread out. We're going to learn about standard deviation today. And transformation, so if you take all your data and you do something to the entire data, you either can add 10, subtract 20, multiply. That's the transformation of all of your data, okay? For example, let's say we took all of our people here and their heights, and we had them wear 6-inch heels, every one of them. It would change their heights, but how would that affect the mean, median, mode, and all that stuff, okay? So it would be a transformation. Make them all wear 6-inch heels, everybody would be 6 inches taller. That would be a transformation, okay? So go ahead and write that down in your journal. There's your notes, okay? And then I'm going to shift over to here, 7-1. So we're going to do this a little bit differently. They want us to do a graph. I'm not going to do a correlation graph. Well, we're not going to do a graph. We're not going to graph. But what I want to do is take this data, find the mean, median, mode, and range. Now, if you have a good calculator, hallelujah. If you do not have a good calculator, you probably ought to get one. Your phone can work, but it's not a very good calculator, okay? So, I don't know how you're going to buy a calculator, but nowadays, I suppose you can go online, but, you know, your phone will. There are nice little apps on your phone that you can get calculators on. Alright, so mean. Mean is just the average. So what I did, I took all of my basketball players. So here's all my basketball players, and you can see I actually rewrote them all in order. And I wanted to do that because it gets the median first is easy. So I went from the smallest, I just line them up from weight. Smallest weight all the way up. So I already did that, okay? I already did that for us. I got the littlest, lightest guy to the big fatty guy right out here, okay? So first of all, let's look at the median. The median's the middle number, okay? Alright, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people, okay? 15 basketball players. So the middle number would be the 8th, right? So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, right? So I get 7 people this way, 7 people this way. That's my median. That's my middle person. So the person that weighs 235 pounds is my median. Stand right in the middle. That's why I line them up from smallest to biggest. Now the mean. Well, I got to do some math, okay? I'm going to add them all up, and I'm going to subtract. So I'm going to take my calculator, okay? So I'm going to do this real quickly. I'm going to take 185, hopefully I don't make a mistake, plus another 185, plus a 205, plus another 205, plus a 215, plus a 235, plus another 235, plus another 235, plus a 245, plus another 245, plus a 255, plus another 255, plus a 295, plus a 325. I get an answer of 3,090, so I added them all up, and I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 by 15 people. And let's find out what my average weight is divided by 15. And I get an answer of 206 pounds. That's going to be my mean pounds. Okay, now the mode. The mode is the most popular. Most popular, okay? Alright, let's check it out. 185, 205, 205. Oh, there's 3 205s. Anybody else? 3 205s? 235, 235. Ah, there's another. So this one's going to be called what we call bimodal because there's 2 of them. So it's bimodal because there are 2 of them that are right there in the middle. So I'd say 205 and 235 are both my modes. It occurs more. Okay, that's a popular. Okay, so it's the most popular. So we've got bimodal because there's 2 of them that have 3 and 3, and that makes those my most popular. Now the range, it's just the biggest. It's like the spread. It's the biggest minus the small, so it's 325. Subtract 185. 325, and we're just going to go 325 minus 185, and again it's for 140. So it's 140 spread in weights, okay? So my range tells you the spread of the weights, how spread out from 325 to 185. We've got 140 pounds spread, okay? Now, let's talk about an outlier, okay? So here's your basketball players, right? And here's our weights. What if we have this scrawny little guy who happens to be a superstar basketball player, but only weighs 95 pounds? What would that do to all of these numbers, especially to the mean? It would really drop the mean quite a bit, and it wouldn't really indicate what our players are like, right? It would really change our range because this is such a small little person. And so then it would affect the whole thing. So that would be an outlier. So most of the time, in most statistics, they throw out your outlier. You don't count it because this wouldn't happen very often. It'd be pretty rare to have a 95-pound superstar basketball player in the NBA, okay? It just doesn't happen that way, okay? So usually you throw out your outliers because they change your data so much, okay? Now, what about a transformation? Well, if all of these guys lost 10 pounds, what would that do to the mean? Well, it wouldn't change the mode probably. Most middle guy would still stay the same, but his number would be 10 pounds less. So if you did that, how would that data transformation change all of this? So it's a good question for homework. Now, all right, here comes the hard part, and that's this standard deviation, okay? Are you ready? You're going to need some paper. You're going to need a calculator because to find the standard deviation, it's kind of hard. So what does this mean? Okay, it's a big, ugly formula. So this little symbol here, you can call it alpha if you want to, but it's a symbol for standard deviation, okay? That's my symbol for standard deviation. And here's how you find it. It's a big square root of all of this. Okay, well, let's see what this stuff means. So the x with a line on top of it is the mean. Okay, x1, x2, x3 is all your individual data sets. Okay, so whether your data sets happens to be all of these. Okay, these are your data sets. Okay, so you take your mean, you subtract it from that. Take your mean, subtract it from that. Okay. So then you're going to take the answers and we're going to square them all up. Take the answers, square them, square them, square them. We're going to take all of those answers. We're going to add all those answers up. Okay. And then we're going to then divide everything by the number of numbers. In that case, in this last example is 15. And we'll take the square root of that. Okay. So what I want to do, we're going to do a problem like that. And I'm going to go through it step by step slowly. Okay. So we are going to go I'll look at question number 3 on page 194. Okay, so I want to do team A so that you guys can do team B. So let me do team A. So first of all, what I want to do is I'm just going to write down my numbers again. I'm going to go through it. So I'm going to do team A. So write down my 58. Okay, these are basketball heights for girls basketball team. These are in inches. 75, so this is how tall our girls are. 60, 48, 56, 78, 60, 57, 54, and 59. Okay, so I'm going to write those down. I want to do this on a separate sheet of paper. What we want to do is if I take a look at A and I take a look at B, what do I see? It seems like Team A is much more spread out in heights. Okay, seems like they've got all the way from 78, and the shortest one maybe is 54. If I take a look at Team B, they seem to be a lot more closer in heights, right? So if we line them up, Team A would look a little bit more like this, in a team picture, or maybe Team B would look more like this. Okay, so standard deviation is going to measure how spread out they are. This standard deviation is probably going to be a bigger number than this one. So let's find out how it works. Okay, step 1. Okay, Let's write this down. Steps. Standard deviation. Okay, it's going to be work today. That's okay. Okay, step 1. Let's find the mean. Okay, and I'm just going to use my calculator to get it. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 girls on this team. So I'm just going to go ahead and use my calculator. You guys can just watch me. I'm going to go 58 plus 75 plus 60 plus 48 plus 56 plus 78 plus 60 plus 57 plus 54 plus 59. Okay, and so I'm going to take my 605 and divide that by 10. That's pretty easy. That's 60.5. I don't need to calculate for that. 60.5. Okay, that's the mean. Okay, we'll put it X and put a hat on. Okay, that's symbol for mean. That's my mean right there. Okay, step 2. And if you want to pause it, get caught if you can. Step 2, what we're going to do is take each one of these data points and subtract it from the mean. Now this is going to take some time. So we're going to have to set this up. So I'm going to go data 1. I'm going to go 58 minus 60.5. I'm going to go 75 minus 60.5. I'm going to go 60 minus 60.5. I'm going to go 48 minus 60.5. I'm going to go 56 minus 60.5. I'm going to go 78 minus 60.5. I'm going to go 60 minus 60.5. I'm going to go 57 minus 60.5. I'm going to go 54 minus 60.5. And I'm going to go 59 minus 60.5. Okay, step 2. Take all of your data points, all of these, and subtract each one of them from the mean. All right, let me do that quickly on my calculator. Okay, here we go. So 58 minus 60.5, boom, I get a negative 2.5. I'm going to go 75 minus 60.5, boom, I get a 14.5. I'm going to go 60, well I can do that in my head, that's negative 0.5. I should be able to do that one without a calculator. 48 minus 60.5, and I get a, oh, try that again. 48 minus 60.5, and I get an answer of a negative 12.5. Okay, this is kind of a pain, you guys, but we're going to do it. 56 minus 60.5, and I get a negative 4.5. Okay, and I'm going to go 78 minus 60.5, and I'm going to get an answer of 17.5. Hopefully I'm not going to make any mistakes. That's a 0.5. I am famous for making mistakes, aren't I? 57 minus 60.5, especially when I'm in a hurry. Well, I will answer that later. Okay. All right. Not while I'm recording. I'm not going to take a lesson. Okay. Phone call negative 3.5. 54 minus 60.5. So negative 6.5. And 59 minus 60.5. I get a negative 1.5. Okay, now, here's what we've done. Step 1, we found the mean. Step 2, we took each data point and subtracted from the mean. Step 3, we're going to square these answers. We're going to square them. Okay, step 3, step 1, find the mean. Step 2, subtract from the mean from each data points. And then step 3, we're going to square these. Okay, so these should always be positive answers. Always positive answers, because a negative times a negative is always positive. If you're going to get a negative answer, you made a mistake. So let's square them. So I'm going to go, for instance, I'm going to go negative 2.5 squared. What do I get? 6.25. 14.5 squared. 14.5 squared. I get an answer of 210.25. 0.5 squared, negative 0.5 squared, and I get a 0.25. Negative 12.5 squared, and I get an answer of 156.25. Okay, 4.5 squared. I just dropped the negatives. I do drop the negatives because I know it's going to be positive. I get a 20.25, 17.5 squared. Hard lesson today, but we can do this. 306.25, 0.5 squared. Now we get a 0.25, negative 3.5 or 3.5 squared, and I get a 12.25, 6.5 squared, and I get an answer of 42.25, 1.5 squared, and I get an answer of 2.25. Now, here's what we do. Step 4, I'm going to add them all up. Take all these. Step 4, we're going to add them all up, okay? So step 1, we found the mean. Step 2, I subtracted each data point from the mean. Step 3, I squared all of those answers. Now step 4, I'm going to add them all up. So I'm going to take and add up 6.25 plus 210.25 plus 0.25 plus 156.25 plus 20.25 plus 306.25 plus 0.25 plus 12.25 plus 42.25 plus 2.5, and I get a grand answer of 756.75. Okay, now take a breath. We can do this. Step 5, we're going to divide that by the number of numbers. So we're going to divide by n. In this case, n is 10. Aren't there 10 girls? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So we're going to divide this number by 10 because that's the number of it. So I'll take my 756.75 and I'll divide it by 10. Okay. Okay, divide this by 10. Answer. So I get an answer of 75.675. Okay, last, I'm going to take the square root of that number. Square root of that answer. This is my last step. So I'll take the square root of 75.675. Okay, so I use my calculator. I'm going to go square root of that answer. And I get about an 8.7. Approximately 8.7. Okay, so we're going to say that they vary. They have a standard deviation of about 8.7 inches. Okay, now why is this important? Well, I would suspect, okay, let me see, I want you guys to see this. So here's my variation. So they have a standard deviation of 8.7 for these girls. My guess is Team B would have a smaller number because they seem to have closer heights. Okay, real quickly, before I'm done, why is this important? Okay, why is this important? Okay, real quick, listen, this is important for us today. So right now, we're stuck in this terrible thing called COVID-19. Okay, I want you to listen to this because this is really what's going on. We have lots of people trying to come up with medicines, antibiotics, vaccinations, right? And somebody's going to make a whole lot of money if they come up with one that works. The problem is they have to test and test and test. They have to take their data and test it. They'll look at their standard deviation over maybe 1,000 people or 2,000 people or maybe 1,000,000 people. They'll look at the standard deviation. If their standard deviation is huge, it's a bad medicine. There's too much variation. If their standard deviation is really small, that means their medicine is probably pretty good. They can then make that medicine. So if they have a small standard deviation, it's going to be a good medicine because there won't be much variance between person to person to person. The medicine is not going to be dangerous, but it will be effective. Okay, so here's your homework for today. I want you to do page 193, okay? Page in your journal, 193, 194. And I want you to do the 1 through 5 all. I already did 4A for you. So number 4A is already done. We just did 4A, but I really want you to come up with 4B so we can compare, okay? All right, that's all I have. Have fun. Good luck. If you have any questions, go ahead and email me. If you're not done with the test from before, you got to get it done.